In exercise 5.3 we're looking at Pythagoras as you apply it to a three-dimensional shape like this pyramid here. So in this pyramid you can see a few right-angled triangles. In the plane across the bottom A, B, C, D we have a flat plane, and when we write that green diagonal line across it we get a right-angled triangle BCD. We've also got a vertical plane there going straight down from the apex at E. EGF is another plane, and that vertical plane has got another right angle triangle in it. We could also have, say, that sloping side, ECB, as another plane, and if we dropped a line down the middle of that we'd get another right angle triangle. Most of these problems involve trying to match up edges in one plane with the matching edge in a different plane. So let's have a look at an example. So here we've got a square-based pyramid, and we can see there that I've got three different right angle triangles drawn from it. I've got my EFG and my BDC, both of those are drawn, and there's another one in the corner there on that sloping face at the front, EFC. I've drawn off to the side the three different types of triangle from the three different planes, and you can also perhaps see that some of the edges there are shared. So in the blue and the black right angle triangles, that's EFG and CEF, those two ones there, they've got a shared edge, and that shared edge is that line coming down the middle of that front face, the EF. So in one of the triangles, CEF, it's not the hypotenuse, it's the long side at the back there, but in the second triangle, the EFG, although it's the same length we're talking about, in that triangle it is the hypotenuse of the triangle. So in these problems we're usually trying to find that length, let's say the length EF in one of them, and then we have to use that answer to then find a different length that we might be looking for, say the height in the second triangle. So let's have a look at an example. So here's a skateboard ramp, and the skateboarder has to ride his board from B across the diagonal face of the ramp across to D. But we don't have that length. We do have the length 9.5, that's how deep it is, and we've got the height at the back of the ramp of 3.5. We know how wide the front of the ramp or the back of the ramp is at 12 meters. We've got to try and figure out that diagonal length. So how can we go about doing that? The first thing to do is to identify right angle triangles in the problem. So if we looked at it from the side, we'd have this right angle triangle CBF. So CBF is a right angle triangle, and we also have this one on the sloping front face, BCD. So what we're going to do is we're going to try and find that shared edge. The shared edge, the edge that's in both of those two triangles, is BC. In our first triangle, BC is the hypotenuse for that triangle on the side, BCF, and in the second triangle it's a side that is not the hypotenuse, that's in the triangle BCD, but it's both talking about the same length, and once we find it in the first triangle we'll be able to use that answer in the second one. So just like the steps in the worded questions from the previous set, the first thing we want to do is actually draw the right angle triangles that we're going to be using in this problem. So you'll notice the green triangle I've drawn there is the triangle BCF. The blue one I've drawn is the one on the front sloping face, and that is BCD. Once I've drawn the two triangles, I then fill out any values that I know about. So in BCF I've got that height of 3.5, and I've got that length of 9.5. if I transfer that 12 meters across from AB down to DC, I can also fill that in the bottom triangle. But in that bottom triangle, I've only got one known side. I need two known sides to be able to figure out that missing hypotenuse. So that's where I'm going to use my answer from the first green triangle and then be able to fill in that extra length in the blue one. So what you want to do is to draw that diagram with the labels on it, the B, F and C on each of the vertices, and you've got the values filled out for any known values, and now it becomes just a simple problem like at the start of 5.2. We're just going to use c squared equals a squared plus b squared, or any of the variations on those formulas, and I'm going to go through and find my answer in the usual way. So I've got my answer from the first one. 102.5 was BC squared, which gives me about 10 meters long. And then I have got that BC shared edge in the second triangle. I can write it in the diagram if I want. But now I have two of the values, 12 and 10.1, that I can put into the formula and then figure out my missing hypotenuse in the second triangle, 15.7. And of course I'm using my reality check, step 4, to make sure that the hypotenuse is not longer than the other two sides added together, but is bigger than each of those separate two sides. So drawing those two triangles turned a difficult problem into a simpler two-dimensional problem. By labeling it carefully, I can keep a track of exactly where I'm heading with the question. So you'll notice that I'm using that system of calling the side not X or Y, I've called it BC, so that there's no point where I'm going to get lost as to which side I'm talking about. So it takes a little bit of getting used to, but I really encourage you to set things out carefully and clearly by labeling everything and having the diagram right next to your working, and that way you won't make mistakes. Or if you do, it should be easy for you to go back through your working and figure out what went wrong. Let's have a look at another example. Okay, let's have a look at a second example. This one is a square-based pyramid, and we've got two right-angled triangles, BCD, and a vertical one, E, F and B, making up our two right-angled triangles in this problem. Again, they've got a shared edge, but this time the shared edge along the line BD only shares half of that length with the vertical triangle, so F to B. So it just makes it that little bit more difficult. So, as usual, we're going to start by drawing those two triangles off to the side and labeling them carefully and making sure we fill in any known values. So first I'll draw that triangle that's on the bottom, BCD. I've got the 8 meters and the 6 meters to fill in, and I've labelled each one of the vertices. The second triangle is the one that is standing in the vertical plane, EFB, and the only value we've got on that is the 10 meters. I'm going to have to try and find the FB length by halving the length of BD. Now that I've got my triangles, I can start applying Pythagoras' theorem. So let's have a look at the first one. Again, I'm using my names as BD, BC, CD. BD is of course going in place of my hypotenuse, and I've chosen to use that modified version of Pythagoras' theorem of C equals the square root of A squared plus B squared. Go through my working and find the answer, just like in 5.2. Then I can put in half of BD into the second triangle. So half of BD is the length FB. And from there, go through my working again and find the final answer. So the key to this is to really make sure that you're labelling things carefully and drawing it out. So let's have a look at the steps again. The first one is identify the right angle triangles that you're going to need and identify the shared edge. draw a separate diagram of each one of those triangles, label them carefully, and fill in any of the known values. When you use your Pythagoras theorem, be really careful, as always, to make sure that you put the hypotenuse in the correct place. And don't forget, try and draw the diagrams to scale and use your reality checks and your scale diagram to estimate the answer, and you'll soon spot if you're making any mistakes. Take it slow, set it out carefully. The last thing to check is whether or not there's anything else you have to do to get to the final answer. For example, it might be asking you to give your answers in centimetres or kilometres or something like that. Or perhaps it'll ask you, how long a piece of string you'd need to hang a light fitting 1 metre off the ground from E or something like that, where you have to do a subtraction or some additional calculation after you've done all your Pythagoras work. So just double check that you have fully answered the question, and if it's a worded question, give a worded answer.